Proposed research work was regarding of the FPGA-based adaptive sleep posture analysis accelerator for real-time monitoring. We are going to have the sleep posture. Here we are having of a totally 3 pairs of sensors we are going to use. One at head level, the other at abdomen level, the other pair was at the point of limbs, lower limbs. So when you go towards the flow chart here, first, whether the subject is available or not. The subject availability is tested by using of a experimental setup, by using of a PIR sensor, whether the human was on bed or not. Based on that, yes, once the subject is available, then the sensor data was going to start capturing. So once the sensor data is captured here, it is going to have the fusion. Means just we are showing off with the experimental setup. One of the human being was under the array of sensors, 6 pairs of array sensors. So from there, right, it's a very initial condition. Then we consider it as a new subject. When a new subject is there, which starts of adapting of their postures as per the standard rules of the sleep posture. So once we find that information, the same is retreated back towards the sensor fusion. Now it becomes as a known information of a subject 1. So this subject, once again, we are going to have at an inference level, we can compare that information and find out what type of posture it was there. So that posture was performed at the hierarchical binary classifier. So the hierarchical binary classifier defines the 2 ways, means it is useful at the 2 levels for us. One at a static posture evaluation, the other one is at the adaptive posture timing. So finally, we are going to find the sleep postures. Here we are having totally we are evaluated 8 sleep postures. Among that, few are there like a left and right and a center like supine and so on. Now comment was here. We are looking into what our novelty was using of a hardware schemes, means developing of accelerators. Very initially we are going to have just now we said a PIR, and we are having of a pair of 6 sensors we mentioned, and H stands for ultrasonic sensor, with a HR stands for the right side of the bed and a left side. So right here and middle and a lower, all we are having. So coming was here, we are having of a other one is a posture learning. Very initially we said in a flowchart the posture learning. Yes, once the posture learning is there, then it fits to the information towards our classifier, and classifier confirms that yes, the learning was regarding our respective posture. So once that was executed at this level. So once the learning has happened over, then immediately it shifts towards the evaluation to send the information to through IoT, through ESP8266 towards the attenders array, the hospital people who are required the posture analysis of the individual or subject. So that, and we also shown a 7-segment display unit here in our FPGA board. We preferred a field programmable gate array. The advantage of this experiment was, yes, we look into the experiment. By that we can understand here. Yes, here we are having of a subject who is in a supine model. So he is sleeping, right? The ultrasonic sensors which we are in our top of this, it's around of 2.3 meters away from a bed. So from there, the human sleep was calculating by using of a FPGA board. That the novelty was we are able to capture the data and compute it totally the information about the sleep postures. All the sleep postures are happening over. One of the novelty of here is the hardware schemes is a novel, and second one is regarding of the especially while the time of learning of your posture may be changed from the subject to subject, but within the classification it is available or not. So if it is a new posture, then it is considered as a adaptive posture also. So for that we are calling as a adaptive posture learning method. Processing element is also available in it. So this was our design approach at the level of a learning process. Thank you.